First question I need to ask, is that the difference of two squares?
Yes.
So if you say it is, then you can tell me what the square root of each of those terms is. What's the square root of the first term?
4.
Which is it?
4x.
4x. 4x times 4x gives me 16x squared. So that means 4x goes in my first spots. Right? Plus and minus. Now what goes in my last spots?
3.
Where is that? 3. Very good. Alright? Straightforward difference of two squares. Pretty easy to work with, right? Let's look at another here. Yeah, exactly. Yeah, you use something.
Mr. Brice, I have a question. Excuse me. My voice is leaving. I have a question. Will they care if you write it as 4x plus...
I see your lips moving.
I'm losing my voice.
Do they care what?
Okay, like if you have an two addition problems, like it says 16x squared plus 9. So would
Did
it...
you say plus 9?
No, I'm just saying. No, I'm just saying. It's just like an example. Like, so what if you have 4x plus 3 and then you put a square at the end? Will they care if you write it like that?
We're going to look at that example. Something very similar.
Okay.
Just hang on to that for a second. First question, ladies and gentlemen. Is that the difference of two squares?
No.
Okay. It is, if you can tell me what I can multiply by itself to get 4xy squared. You got anything in mind?
2x.
4xy times 4xy, I'm sorry, 2xy times 2xy is 4x squared y squared, not 4x y squared. You got something I can multiply by itself to get 4x y squared? 4
Is it 2 more?
And then do y squared minus...
Oh, wait a minute. Did we not say always, first of all, look for the common factor? And what did you notice is a common factor? So let's answer the first question. Is that the difference of two squares? No, it's not the difference of two squares. There is nothing without extraordinary measures that I can multiply by itself to get 4x y squared. What's the problem in the 4x y squared? The x. Yeah. The x, the 1x is the problem. So here's what your observation is going to help us to resolve. I see a 4x in common. Let's take it in. That gives me y squared minus z squared. Now, ladies and gentlemen, what do you notice about what is now in parentheses? Difference of two squares. Remember, I told you sometimes, and here's an example, you're going to look at the first statement and go, I can't do anything with that. It's not the difference of two squares. But then you're going to take out a common factor, and what happens? Difference of two squares is revealed. So now I can factor the y squared minus z squared. That's just the difference of two squares. Don't forget your x squared is still, your 4x is still there. It's just that this guy factors into two binomials, y plus z, y minus z. Is that all right? Please keep that in mind. Always look for the common factor first, because sometimes, as in this case, it will reveal something that can factor further. Yes, sir.
The 4x doesn't have to be multiplied by the y. You need just one of the two.
Just one of the two. Exactly. Please keep in mind, ladies and gentlemen, that multiplication of items is not distributed. This is not the distributed property. Distributive is when you're multiplying something by a sum or difference of things. This is multiplying by things multiplied. So just like you could say 2x y is 2 times x times y times y. It's not 2 times the x, then 2 times the y. It's just 2 as a factor, x is a factor, and y is a factor. Likewise, this guy right here. Just a factor. You can put it in between if you want. You can put it at the end if you want. Doesn't matter. Just multiply it once. All right, last example. On this page, start to look slightly familiar. Question, is this the difference of 2 squares?
Yeah. No, not in this form.
Not in this form, it's not. What you going to do? There you go. Factor out 5y. Right? You see what they have in common? 5y. And what do you have left? X squared minus c squared. Hey, this is a pretty good question right here. Is this the difference of 2 squares?
Yes.
So you're saying x squared is a perfect square, right? That's kind of obvious. What times itself gives you x squared? X. You're also saying this is a perfect square. What times itself gives you z to the 4th? So it says z squared times z squared gives you that term right there. That's a perfect square. So yes, this is the difference of 2 squares. It factors into 2 binomials. Square root of this guy, here and here. Square root of this guy, here and here, plus the minus. Okay? All righty then. Let's go here. And let's ask some questions here. All right, first of all, is that the difference of 2 squares?
Yes. Yes. Yes.
Who dared to say no? Why is it not the difference of 2 squares?
It's not.
Oh, it's not a difference. Oh, you mean the difference of 2 squares has to be a difference? I'll bet you're right. This is, for lack of a better term, the sum of 2 squares, right? Okay? This is not the difference of 2 squares, so it doesn't factor in the difference of 2 squares method. It's the sum of 2 squares. How's this guy going to affect? What do you think?
X plus 7, X plus 7.
X plus 7, X plus 7. And we got plenty of time on this test, ladies and gentlemen, so let's go back and check. X plus 7 times X plus 7, that's X squared, plus 7X, plus 7X, plus 49, that's an X squared, plus 4X, plus 40. That didn't work. Because x plus 7 times x plus 7 is x squared plus 14x plus 9. Let's go back to the drawing board.
X minus 7.
X minus 7.
And then X minus 7 again.
X minus 7 and what?
And then X minus 7 again.
And x minus 7 again. All right. Let's check since we got all this extra time. That's x squared minus 7x minus 7x plus 49. That's x squared minus 14. Good thing we got a big drawing board here. Back to the drawing board. Yes, ma'am. That's the same as x plus 7 times